Hello everyone, welcome to my channel. So in today's video, we are going to learn about how to construct an anti-Ackerman geometry. Okay, so it is a type of steering geometry which is used in performance vehicles. Okay, so in front of our screen, we have this PPT in which we can see on the left hand side, vehicle front and vehicle rear, and the red dotted section represents the steering geometry. So it is a front steering geometry, and the detailed view of this has been given on the right hand side. So you can see 1, 2, 3, 4. These are the various parts of which this steering geometry is made up of. Okay, so you can see number 1 is steering rack, second steering rod, third is steering arm. Steering arm is a part of steering knuckle. I have not included steering knuckle in this. So, and steering knuckle is connected to the wheel spindle, and wheel spindle is connected to the wheel hub, which connects to the tire. Okay, so we are going to understand about the construction. Okay, so the construction of the steering geometry, and we are talking about anti-Ackerman steering geometry. So as you can see here, I have got a basic layout. In this, we have a front box and front tires and rear tires. Okay, so you can see this steering geometry. Okay, it is a anti-Ackerman steering geometry. So one of the basic way to find out or identify a steering geometry is that if you draw a line which will join the front wheel center of the front tires, so that axis. So the steering rack will be usually the in front of that axis. So you can say it is a leading arm. You can say leading arm type steering. Okay. Normally in anti-Ackerman geometry, we have a leading type steering arm. Okay. In Ackerman geometry, we have at the back side. So that is a trailing type steering arm. Okay. So this is 3D which I have made. Okay. So in this, you can see the right hand side steering arm. Yeah. So the position of the rack, the steering rack, depends how much leg room you want and what is your packaging you want to do at the front, and also what is the height and the length of the steering rack. Okay. So this is our knuckle body. It is represented with the following lines, and this is this line. That line is the steering arm. Okay. So yeah, so steering arm is connected to steering rack through this line. So that line is called as steering rod, or you can say tie rod. Okay. So when the driver will move the steering wheel, the rack will move, and since the tie rod is attached to steering rack, it will turn the vehicle with the help of a steering knuckle. So we will start with basic. Okay. So how to make it in 2D first, we will look at. So open a new part file. Okay. Now press Ctrl plus 5. It will open the top plane. So I want to sketch in a single plane. Okay, so it is not a 3D, it is a 2D plane. So the diagram previously, it is a 3D steering geometry. But to understand from the basic, we are making it in a 2D plane. Okay, so first of all, we will make the wheelbase. So taking a midpoint line here, give it a length of 1750. Like this length and all is all hypothetical, not very much hypothetical, but comparable to the real world vehicles. Okay, so now the track width, this is rear track width, and this is the front track width. So track width we are keeping around 1500 mm. Okay, so these both are equal. I'm keeping them equal. Okay. So select all the three lines. I'll make it as construction lines. Okay. So now the tires. So I'll be making using center rectangle. So this is what we are looking from the top view. Okay. Your top view of the vehicle will look like this. So 150 tire width and the tire diameter. Let's give around 500. Okay. Similarly, we will make for others. Okay. So what I'll do now is I have selected this line and select all the horizontal lines of the other rectangles and make them equal. Similarly, this vertical line and all the other vertical lines which are not defined. So like this, make it equal. So all the four will become equal and defined. Okay, so you can name this sketch as tires and layout. Okay, so again I will open a new sketch and here I will make the steering geometry. Oh. So take a midpoint line, and when you place your mouse here, you can see an imaginary line. So that will give you a hint that this is the middle point, and you just make a line horizontally. Make it horizontal and connect this line through the center. Okay, so let us keep it at a distance of the front axle, let's say 200 mm. Okay, so and the length, let's keep around 350. Okay, these all things can vary, this distance, this length, okay, based on your performance you require and the design requirement and boundaries you have. Okay, so now we will make a spindle. So this is a wheel spindle I am making. Okay, so wheel spindle, this is wheel center, and from the wheel center we have made it. Okay, let's say it will be 125 mm. Okay, now we have to leave some clearance because we will connect the steering rack to the steering rod. So some sort of, margin has to be left because here the ball joint or Heim joint will come. So I'm leaving around 30 mm clearance. Okay, so to connect for various purposes like welding, or if you want to apply a screw mechanism, you can nut and bolt that. Okay, so but this will not be counted into the actual steering rack length. Okay, so so by this point, which is after the clearance, this will represent the center. Okay, so center where the rack connects to the steering rod. Okay, so now we need to have a steering arm. So this is spindle, and in the top view, your steering arm will be directing towards the vehicle, which is this side. So you make a line like that. So angle is totally based on the performance and how much anti-Ackerman percentage you want. So I'm keeping 105 degrees. Okay. Length, let it be 125. Okay. So yeah, again, clearance you give. It is up to you, like whether you want to include the clearance into the main length or you want to give separately. So make sure this line is collinear and give a length to this also, which will be 30 again. So clearance has been given here. Clearance has been given here. Okay. So now you can make it like this. Okay, because clearance has to be given in the tie rod also. So make sure these three lines, okay, are collinear, and these two are construction lines. Okay, this is the main body of the steering arm, steering rod. So we can keep this clearance to be 30 again. Okay, and this also we can keep 30. Okay, so this will be the length, which will be around 300 something for the steering rod. Okay, if you see now if you hide the dimensions, your steering geometry for the left hand side will look like this. Okay, so this is your steering rack, steering rod, steering arm, and spindle. So this is how it will look like in top view, and this is pretty much 3D. Okay, I wanted to start from this so that if you directly jump to 3D, it will be a little bit difficult. But since we have got the clear idea, we can make the 3D. Okay, so if you want to make for the right hand side, you can mirror this. So this line, these also, or you can simply drag like this. Yes, and do mirror about the center axis. You need to click on that. Last line I will remove. Okay, we have left one, so this line, yes. Okay, so that will be all. So yeah, this is your steering geometry, anti-Ackerman steering geometry. So what we have done just right now is we have understood the construction, like the construction process. Okay, how to make anti-Ackerman steering geometry. Okay, there are a lot of technical things like the positioning of the steering rack, the angle, steering arm angle. Okay, the steering arm angle, spindle length, steering arm length, steering rod length. Okay, the steering rack length. Okay, and so these are the design parameters which will affect the performance. And there are other parameters as well, like if you zoom out, you can see the position of CG. Okay, your turning radius, and inner steering angle, outer steering angle, and how much anti-Ackerman percentage you want. Okay, the more anti-Ackerman percentage you will have, the more sharper the vehicle will be able to turn, but there are high chances that it will slide. Okay, because anti-Ackerman steering geometry type promotes the ability of the vehicle to slide when turning, Okay. So yeah, so if you compare this with the 3D, it will be like this. Okay. So in the next video, I will try to make the 3D, the steering geometry in 3D. Okay. And yeah, that's all for today's video. If you have any query or any point to discuss, you are welcome to drop it down in the comment section and let me know if is there any way I can improve and in my explanation and other things, or any of your doubt, you can please post it in the comment section. Okay. So thank you all for watching. Thank you so much. See you next time.